Okay, good morning, everyone. So I'd like to welcome you to our Spring 2010 IAB. We have prepared an interesting program for you on a topic of current interest in our community, which is the future internet research theme that we are covering today. We have not only WINLAB talks, as usual, we have some talks in the morning which give you summaries about WINLAB activities in this area. And after that and throughout the day, we have external speakers who represent different collaborations that we have across the community. And we are very pleased to have several invited talks and student research talks from our collaborating universities like UMass, Wisconsin, Michigan, and so on. Also, we have a terrific keynote speaker for you today, Chip Elliott. He's the head of the Genie program at BBN. And Genie is something that Chip and I have been involved with for, I would say, about 5 years now. And it has not been an easy ride, but it's actually beginning to look quite good now. And I'm hoping that he can give you a perspective of what has been accomplished and what the future vision of Genie is going to be. With that, let me just get started with my first talk, which is an overview about what WINLAB is doing in the future internet research area. I don't want to duplicate too much. Some of the more detailed talks will follow. So my plan is just to kind of rush through some of my material to give you a sense of what the topics that we cover in our research program. And after that, you'll hear more detailed talks from people like Ivan, who will talk about our Genie program, Shweta, who will talk about our CNF architecture, Gautam, who will talk about some of our Genie projects. So you will get a pretty detailed idea from that. At 11 o'clock, we are going to switch to our keynote speech. And after that, we have a lunch. And then, as you may have seen from the program, we had one change in the final program. We are going to do the research talks in the afternoon, but we will postpone the poster session to the end of the day. So at 5:15 in the area outside, you will see the poster session will be set up. And many of our students will be happy to discuss their projects with you, and you can ask questions. And the posters we have are not limited to future internet. They cover a range of topics that are going on at WINLAB. And then at 6:30 we have the dinner, which will also be in this building. So if we really would enjoy your company if you can make it. If you haven't already signed up, you can do so. So just tell one of the ladies in front, and they'll put you on the list. So with that, let me get started with the first talk of the day, which is Future Internet Research at WINLAB. So before I go into what we are exactly doing, let me give you a perspective of what our James, maybe can we dim some lights, James? So the perspective of future internet is all about wireless, which is not a surprise to you. As you know that we are going through a very interesting trend in the information industry. Of course, everything is moving to the internet, but at the same time, the internet is moving to the cell phone. So in that sense, there's a very interesting convergence phenomena that we are seeing from a technology point of view and from a business point of view. The picture I have here is kind of a simplified representation of the fact that today we have a snapshot of something where perhaps we have 1 billion connected devices to the internet, but the proportion of these which are mobile and wireless is going to rise very rapidly. I was interested to read a white paper from Cisco recently, which predicts that by 2012, we will see a crossover of traffic from mobile devices and fixed devices, in the sense that just as the cellular network crossed the fixed telephone network about 10 years ago, we are going to witness the transformation of the data industry, moving mostly from fixed platforms to portable platforms. And I think that given that the market leader and many others have done detailed studies, I don't think there's much doubt about it. There's also current data in terms of the exponential growth of the data services that we are seeing right now. and it will be very interesting to see how all this plays out. Now, what does all this mean for the internet? When we move things over to the right-hand side of this picture, you see that we have a lot more mobile devices. We have smartphones, we have laptops, many other kinds of devices, sensors which are now connected to the internet. Today, most of these are not directly connected to the internet. As you are aware, most devices wireless devices that we use today first go into their own network. The cellular network, 3G network, for example, has its own address architecture. It has its own handoff protocols. Everything is actually non-IP. And then there's an IP gateway somewhere where the IP address world is translated into that particular regional network or cellular network that you're working on. And this sort of works today. But at a very large scale, it has many problems. And one of the biggest problems is that it's very difficult to have an open application framework when you have all these complicated gateways and a multiplicity of protocols. And of course, there's a technical issue of scalability when we have 10 billion devices, mobile devices on the internet. How do we deal with mobility, for example? These are all hard questions. So before I talk about some of the solutions, just briefly mention some of the vision that WINLAB feels that we have to consider not only the existing mobility scenario, which is typically one cellular link. It doesn't always have to be like that. And I think from a research standpoint, there are many interesting wireless scenarios that go beyond this simple model of a cellular network which is interfaced to the internet. Of course, that will be the biggest industry driving transformation where cellular will be merging with the internet, both in terms of industry as well as technology and standards. And I think that's inevitable. It will happen very fast, and by 2020 I can predict there will be only a single standard for these things. Okay, now in terms of some of the more researchy wireless scenarios, let me just walk through a couple of them in order to motivate what we are working on. So the first scenario that we have done quite a bit of work at WINLAB is that of dynamic spectrum and cognitive radio. And one could argue that this is not really an internet issue. It's a radio technology question, but I think radio technology, if you accept the point I made just before this, that there's going to be a complete merging of radio industry with the internet industry, then cognitive radio and is a new emerging radio technology which will have a big impact somehow. And one of the impacts that we see is going to be that cognitive radios use spectrum dynamically, and spectrum is something that is becoming one of the biggest bottlenecks. It's certainly one of the more expensive resources that we need to be able to deal with when we access the mobile device. So I think in that sense, spectrum plays a much more important role in future internet, and how to use dynamic spectrum from a policy point of view, from a protocols point of view, is one of the focus areas of research in this area. So it's an important scenario. I won't go into the details of what we are doing in white space and spectrum markets and so on, and you'll hear some of that in the talks today. But it does have a bearing, and in terms of the protocol level issues, there's a lot of question of how do you deal with radio level cross-layer information deep inside a protocol stack, which is something that you cannot do today if you're using an IP protocol. A second interesting area that sort of emerged in the last few years is that of network MIMO and cooperative physical layer. Cooperative physical layer is sort of a general framework for getting significant improvements in bits per second per hertz or spectral efficiency, modulation rate, and so on. And we're all familiar with the fact that MIMO has moved in and is become quite mainstream, because MIMO gives you, with multiple antennas, you can get significant capacity improvements over simpler single antenna systems. The next step with all this is going to be some forms of cooperation across the network, and this has some nice, interesting implications. So if you look at the picture below, you see this is a case where multiple signals are picked up by different base stations, and then these are combined in some way at the signal processing level. So this has some interesting implications for the network. It requires multi-homing, multi-path routing, things that we can't easily do with today's IP protocol. And also we have to have super high bandwidth to be able to deal with some of the signals themselves in order to do MIMO combining. So this is something that has, again, it's interesting from a radio research point of view, but it's also has some implications for network architecture. Another area which has been studied a lot in our community is that of wireless mesh network scenarios or multi-hop relay that occurs in cellular networks, for example. There's a general belief that as wireless systems become more and more congested, it will be necessary for us to exploit multi-hop transmission in the appropriate way. A multi-hop is not a panacea for every scenario, but there are a lot of interesting scenarios in the home, in urban networks and so on, where multi-hop can play an important role in improving radio density and providing spectrum efficiency and power efficiency. So multi-hop could be used in many cases, and it has already been tried in many first-generation scenarios, not with much success. But as you know, the Newton was introduced 10 years ago, and it was a complete failure from Apple. If those of you who haven't heard of Newton, which was Apple's first iPad or iPod or whichever one you want to call it, it was an absolute failure. But it came back 10 years later, much renewed and with a better design, and it became immensely successful. So mesh network is a case in point where the first batch of products wasn't very well designed. Some of them were rushed out, and they were applied to certain scenarios where the business case wasn't very good. But there's still some technical potential for mesh and multi-hop applications to emerge. And certainly the near-term opportunities for a couple of hops with LTE relays, for example, and these are areas that WINLAB has been doing some work. And what does all this mean again for networks? So of course, once you do multi-hop over the radio, it's no longer just a link that you have to attach somehow. You have to do routing in that network. So how to do routing and how to support extensions of IP routing that deal with the requirements of mesh network is sort of an open issue, and people have some understanding, but within IP community, there's not been that much work done other than the MANE standard that was put out some years ago. So again, this is something that would be a part of this ultimate integration. And as you can see also with sensor networks, where you have a tiny device, it will be necessary to do multi-hopping in any case because you won't be able to reach that device with full power. So there's a lot of interesting protocol ideas that stem from that. Another scenario that WINLAB has worked on for years is that of P2P or DTN. DTN stands for delay-tolerant networking. P2P you're familiar with, but wireless P2P is sort of the picture shown here, where a bus is moving over a roadway, picking up data from sensors. It then downloads the data opportunistically when it reaches some coverage area. So these kind of applications, or you have a car which is passing through some kind of a parking lot entrance, and it gets a download of a newspaper or some kind of update. So these are applications where you have partially connected networks, and this is the reality today, that wireless is always going to have big variations in coverage. And there will be some areas where you have a hotspot with super high bandwidth and other areas where you have low bandwidth. So in order to exploit that, we need network protocols that can deal with this vast, rapid changing or very big range of bandwidth, access bandwidths, and full disconnection as the case may be. And in those cases, what kind of network do we need to support that? So clearly IP is not a good fit for that. If you use TCP end-to-end, you're not going to get any throughput in this kind of application. So people have designed overlay solutions for that. We ourselves have been looking at solutions in which the idea is to integrate, put storage into the network, and in that way create a network which is more robust and can deal with this kind of scenario. And this is very important in our opinion. You'll be hearing more from Shweta about cache and forward CNF, which is one of our projects which tries to build a uniform network architecture that works across the full range of wired, wireless, disconnected, not disconnected, bandwidth changing. All these things can be dealt with in a single network framework, which ideally is not that far from IP. So this is something that we'll hear more about later today. Another area which is very active at WINLAB is led by my colleague Marco Gruteser. and Rich Martin here, who has been working on the location aspect of this. So what we see is that there's a lot of interest in vehicular applications, and certainly it's a market where there are hundreds of million new devices. So now that every 5-year-old has a cell phone, one of the big targets of the industry is embedded applications. Like every car has its own radio. It is used for V2V, which is sort of local applications where you avoid collisions, for example, or it's also used for V2I, where the car talks to the infrastructure. And each of them has some protocol implications. Of course, there's the classical high mobility aspect of this, which we have been studying in our community for 20 years, how to do mobility, mobile IP variations, mobile IP v6, new ideas that go beyond mobile IP. But beyond that, there's also a need for short-range communication, which has a geographic awareness to it. So we have some projects which deal with that. And location is sort of the key to all of this. So instead of address, location becomes perhaps the most important attribute that you deal with in these networks. And of course, there are very interesting radio issues as well that come up. How do you transmit reliably to 100 cars around you? These are not simple problems. So it has implications both for radio technology as well as protocol architecture. Okay, so finally, I just mentioned that you can also look at pervasive systems as a broad area of research, and it's something that's coming in the future of the internet. As the internet matures, we're going to see more and more machine-to-machine applications, and with it comes a change in the role of the internet. The internet today is mainly a network that connects to addresses. Once you go to machine-to-machine, there's a lot more computation-centered kind of applications which require awareness of context, for example, require some computational backend in the network, which sort of ties into these big buzzwords of cloud computing and so on. I'm not sure that cloud computing as defined by certain companies are going to match what we're trying to say here, but from a research point of view, the protocol design that supports pervasive networking, where you have tiny sensors, machines which interact automatically and opportunistically, have geographic and context awareness. All these are important areas that we're working on. Okay, so with that background, let me just finally summarize what we think are some of the architectural implications of all this. So if you want to put all this together and say, okay, what does all this mean for the future internet architecture? First of all, we want to state here up front that we don't expect the internet architecture to change overnight. We are not claiming that we can just do a clean slate redesign of IP and expect that the whole world will adopt it. But we can adopt a methodology where we look a bit beyond IP. We don't stop and say, okay, because IPv6 doesn't have this, it's not worth doing research on it. So we have taken a slightly different approach, encouraged by our community projects like Genie and Find have had this philosophy that let's at least study the problem without the constraints of IP, and then we'll figure out how to find a reasonable and practical strategy to deploy such networks. And it might happen through revolution, evolution, some combination of both. We don't know how exactly it will happen. And there are new technologies like virtualization, which you'll hear from speakers. Like we have a Stanford talk about virtual networking technology as well, which will allow us to make it easier to bring in new network protocols as we go along. So in this, I'm just listing here some of the big changes that we need to deal with the wireless world that I've summarized. One is that we have to deal with dynamic spectrum. We might need multi-point high bandwidth connectivity. Cross-layer protocols support user and router mobility. Not just the user can move, but the bus, which is the network itself, can move. So network mobility, we have a talk from University of Michigan about how to deal with that at a global scale. In-network storage, which corresponds to the talk that Shweta will be giving about CNF. Integration of geographic location into routing, addressing content and context awareness, in-network computation, and we also have Bill Lair from MIT who will be speaking about economic aspects, and that remains again very important in order to achieve some of the goals of any future architecture. So this is the laundry list, and I just want to mention a couple of things about our projects at WINLAB. One is that we have been funded primarily by an NSF initiative that started about 5 years ago. There are two programs which, for those outside the NSF world, in industry, these acronyms may not matter much to you, but we have actually been working on building up some support within NSF and the funding community in the US to do more research on open-ended architecture for the internet. There was first a Genie project effort that started in 2006, which aims to build experimental network infrastructure at a global scale in order to enable protocol research of the kind that we are talking about. And this includes both wired and wireless aspects. And then the FIND project, which is a related project, which was a program that NSF started in order to promote clean slate thinking to the design of next generation protocols. And each of these programs has many counterparts in other parts of the world. In Europe, there's a very large program called the FP7 program, which has funding to do similar things. And countries like Japan and Korea have also started formal programs in these areas. So there's quite a lot of activity worldwide, and I think it bodes well for some innovations in the near future. There's a new opportunity that I should mention here that is called FIA, which is the Future Internet Architecture Program that NSF announced recently. This is a little different, where the idea is to have a large team come together and make an ambitious proposal to build a comprehensive architecture that can run on whatever test beds and other infrastructure that you can find. And right now this competition is underway. There will be a few awards, I believe, made sometime this year. Okay, so those are the programs. And in terms of what WINLAB has been doing, let me just give you a summary here of our timeline and the projects that we've been working on. So our work is classified into two different areas. One is on the research project side, where we are looking at architecture, wireless protocols, integration of wired, wireless, coming up with new mechanisms at the protocol level. And below are prototyping projects, where we were trying to build test beds and open infrastructure that allow the whole community to build on these new ideas. So starting with the prototyping aspect, as you know, we have had the Orbit testbed at Rutgers since 2005, and that was an ongoing project that preceded this future internet area. After that, we sort of continued with that. Orbit became a platform that became quite useful to the future internet research community, and we have added to it features like virtualization, wired, wireless integration, and so on, to demonstrate that, in fact, you could build large-scale testbeds which had a significant wireless component and be able to do meaningful programmable experiments on those. So again, Ivan will be talking more about that in detail. From it, we went to the more formal Genie projects, which Chip will be covering. Genie started with a Spiral 1 approximately 2 years ago, and in it we had two projects. One is the WiMAX Open Base Station, which you'll hear from Gautam about later this afternoon. And we have also a project on OMF, which stands for the Orbit Management Framework. It's the control protocols that you need to build a large experimental network. And those were the two projects that they're still going on. And then the Spiral 2, which started recently, includes projects on extending the Genie WiMAX to multiple campuses all over the country, a joint project with Stanford, which you'll hear from Masa about, on Genie OpenFlow campus networks, which is led by Stanford, and we are a partner in that. And then we have a small proof of concept prototyping project on a new, very promising new software-defined radio platform, which could make it interesting for people who want to try new ideas in areas such as cooperative communication type of projects, which I mentioned before. So this is the landscape of what we have at WINLAB. And I have some more slides which we'll just post on the website. I want to hand over to my colleagues and others who will give you the more detailed talks today. I'm going to skip those. I had one slide each for each project, but in the interest of time, let's move on to the detailed speeches themselves. I can answer a few questions if you have any general questions before we get into these talks. Any questions or clarifications? Yeah.
since you talked about business models, for the particular DTN setting, as well as one more that you're talking about, can you give a sense of what the business model is?
For DTN services?
Yeah, and just vehicular P2P, B2B sort of.
Yeah, so I think the most common application today is content delivery of different kinds. So if you look at content delivery business models, there's one illegal business model which is very successful, and there's a couple of legal ones which are fairly successful, like Akamai. So if I look at the wireless DTN scenario, I think an Akamai-like wireless content delivery service model could be quite attractive. I think Apple is inching its way towards that anyway, where there's this notion of you go to a hotspot and their app server will prompt you to download something, whatever. But these will gradually become more automated and seamless. So I think the business case is there. Now, what's interesting though about DTN is just a term. If we talk about adding storage to the network, I think there's a business case in general for any service. I think there's a model where such protocols can give you improved throughput and robustness. So there the business case is for the operator will have an incentive to deploy such technology. Okay, we have a business expert, so when economics expert here, Bill Lair, so when he speaks, ask him more questions about that. Okay, so any more questions before we start? Okay, so in that case, Ivan, you're next, right?
Assuming my slides